Welcome back, dear students, to this awesome lesson of data structures. Today, we are diving into a more interesting ADT, which is a stack. Very important. I'm sure you must have heard about a stack when we were talking about recursion, whereby we learned that the different recursive calls that are made by subroutines or recursive functions are with the use of a stack. Now, let us dive in to understand more of what a stack is. A stack is a LIFO, that is the last in, first out. A stack is a LIFO linear data structure in which an item to be added to the stack must be placed on top of the stack, and items that are removed from the stack must be removed from the same top. So in contrast to a queue whereby items are added at one end and removed at the other end, a stack instead items are added and removed from the same end, which is the top of the stack. Take an example like when you have a lot of books that you are placing on the table. If your junior brother comes and gives you a book that is it's the last book, that will be the book you will place on the pile of books that were already there. Now, if you have, for example, your brother who just need a book in order to place as a in order to place a paper to write on it, let us say as example, the book you will give him will be that first book that you were just placing on top. So instead, the last book that was being placed on the pile of book will be the first you will take and give. That's just like an illustration of a stack. That is when you have a lot of elements arranged in a list, the element you are just from adding, in case there is a removal that should be done, that element you were just from adding will be the first you will take out. That is how it is. That's why we say it is a LIFO linear data structure. Linear because the elements are arranged sequentially. So this is what we have of a stack. As you can see, this is the top of our stack. If I want to add an element, the push operation is where it is done, and when I want to remove, it is from this same top, as you can see. Now, just as a queue, a stack has operations. Like we have the push data. The push is what we use to add an element in a stack. Can you remind us about the operation we use in adding an element in a queue? Perfect. Enqueue. Okay, the next it is a pop. A pop is what returns an element from the top of a stack. We know that in a queue it is a dequeue operation. From there we have is empty, just like in a queue. It checks if a stack is empty and returns true. If it is empty and returns false, if it is not empty, then we have is full, we have size, we have peak, which returns the element at the top of the stack without removing it. Very important. Now, just as we did with queues, let us take an example to better understand how these operations are performed on a stack. The Bamenda Ashjosesan Mock 2022 question 4. That's a full question. For the sub 4, there was a B part which was not actually related to this chapter. That's why it is not there. But when we look at this question, we see that this question data structure came for 8, 9, 10, 11, 12, 14 marks. Having 14 marks on a question in computer science out of the 17 allocated marks, it is awesome. Okay, let us proceed. The question says, consider the following stack of characters where stack is allocated n equals to 8 memory cells. As you can see, 1, 2, 3, 4, 5, 6, 7, 8. So these 3 cells are empty. Describe the stack as the following operations take place. We have A, B, C, D, E, F, G, and H. So the A says that word, pop an element. Which element are we going to remove? Is it A? Okay, let us see. First of all, initially, this is how our stack is, because remember, if a stack is empty, it means that it is at the top, that it is being empty. So this is the bottom element, followed by C, D, F, then K, as you can see. So if you perform a pop operation, which element shall be removed? As you can see, elements are removed from the top, so it is K that is going to be removed, as you can see. B says pop an element again. So from here, if we pop, it is F that is going to be removed. C is the same thing, so it is D that is going to be removed. D says push R. So this is what I'm going to have. I am adding R, and you know that addition and removal are done from the top. At the top, sorry. E says push L, addition of L. F says push S, so I'm adding S here. This is what I'm going to have. Then G says push P. This is what I'm getting. You see that the stack is gradually getting filled. Then H is saying pop item. And if you are popping, which element are we removing? The last element that was added, which is P. So this is what I have. So dear students, this is what you were supposed to do to earn all the 8 marks. I told you, remember in one of the video here, that if you want to grab in more marks in computer science advanced level, it is not by going through chapters that contains a lot of literature, but by going where reasoning is needed. Because in such question, there are more marks and less work to be done, especially for students who will pass through our channel. Sub 2 A. When will overflow occur? It is true that some students texted me after watching the video on queues asking me what overflow is, because remember in our algorithm there was overflow when we were testing to see if a queue is empty. So what do we have? Note, underflow is a situation arising when we pop out an element from an empty stack. Not even when we pop, when we are trying to pop out an element from our empty stack, that we call underflow. That is, a stack is empty. It's the same thing for a queue. That is, our data structure is empty, but you want to remove something from it. That's total, that's magic, dear students. That we call it underflow. A situation arising when we pop out an element from an empty stack. If it is related to a queue, a student can simply say underflow is a situation arising when we dequeue out an element from an empty queue. When it comes now the other way, pushing an element in a full stack is result to overflow. So if a data structure is already full and you try to add an element again, it leads to overflow. Dear student, just like you are having a container of water and you're adding water in it, once the container is full, the other quantity of water you will try to add will just be flowing. That we call overflow. That is it. Now, it is true we don't have a maximum number of subscribers you can have to our channel, but I will be very happy if I could have overflow of subscriber, overflow of likes, and overflow of comments. Well, let us proceed. I hope the terms underflow and overflow are okay for everybody. Now, the helper says, when will overflow occur? Now that we know what overflow is, overflow, since the stack has been allocated 8 memory cells, as you can see this here, they say the stack is allocated n equals to 8 memory cells. Yes, so don't ask yourself that where is the 8 coming from? This is here. It is given in the question. So since the stack has been allocated 8 memory cells, overflow will occur when the stack will contain 8 elements and a push operation will be done to add a 9th element. Remember that what is in blue must not necessarily be present in your answer. It is just there as an explanation for you guys to understand better, because I could not just say overflow will occur. I needed you to understand why my answer is like that. Remember, you are in an awesome channel where everything is broken down byte by byte, not bit by bit, but byte by byte. So that is when overflow will occur, when our stack will contain 8 elements and a push operation will be done to add a 9th element. B is asking, when will C be deleted before R? When we look at what we have here, we realize that R is above C, and on a stack, an element below can never be deleted before an element above. So stack is a LIFO data structure, hence C will never be deleted before R. So that what we have, C will never be deleted before R. Then the sub 3 part says, in relation to the array data structure, string name, which contains this sequence of string entries. Remember, I told you that string is a group of characters, and you see that string name is simply what? An array of strings. Yes. Now they say, state the main role of an index in accessing elements of the array. Remember, we talked about index, and the index helps to specify the exact location of a particular element of the array. B says, what is the value of string name position 5 if indexing starts from 2? So they're telling that what at the first position in our string is 2. Now let us illustrate this. This is what you are going to have. As you can see, they say the first index is 2, meaning that Smith is at position 2, the next at 3, at 4, at 5. So as you're asking, string name 5 be what? It will simply be Brown. Yes, string number 3 is NG, but the question is asking for string at position 5. So it is instead Brown. So this is just a problem because I remember this same question came in another mock and we were being asked at the name at position 3. So position 5, as you can see, is Brown, but at position 3, as you can see, C is NG. Now, sub 4. Write an algorithm for adding corresponding elements in two arrays of integers. Both arrays are of the same size. So this is simply what you are going to have. Algorithm addition. Remember, I told you when we were writing must know algorithms concerning arrays. I told you that when you majority of the algorithms you are writing concerning arrays must be made using a loop, or precisely the for loop. And here we are simply taking one element from the array with the other element from the other array, we add them and we insert the result at the same position but in a different array. That's why you see here from count equals to 1 to n, because in my declaration I am having what? My index starts from 1. So from 1 to n, sum at position count will be what? The value of array 1 at position count plus the value of array 2 at position count. And that is all. That's the algorithm for 2 marks. So that is the solution for this part of the Bamenda Ashijosesan Mock 2022 question 4. Let us proceed, dear students. Exercise. I am waiting for the solution. The Northwest Regional Mock 2022 question 4 sub 3, that's what we have. This particular part, I'm the one who just added it. I want the answer. Maybe in the comment if you want. Another student, since I will like you, dear students, to give your answer in the comment section, because you can just give the contents of the stack in text form, that is using square braces as the beginning and the end of the stack, and you explain when overflow will occur. I am waiting for your answers in the comment section. Then the Northwest Regional Mock Steel 2022 question 4. No, this is normally, I remember this question, this is the Bamenda Mock 2023. Yes. So the question says, a stack operation is given as s.opxp, where s is the stack, opx is the operation to perform, like one of these, and p the parameter to use. Show the contents of the stack S after each of the following operation 1 to 4 have been performed. First of all, this is what we have. Our stack is empty. And now don't ask why I'm having just 3 cells, because you could still have 4 or 5, because the year does not precise the size of our stack. The first one says push 2. What is the function of push? Add element. So we are adding 2. So after number 1, this is what I am going to have. As you can see, I'm going to add 2. Then second one say we should add 4. And 4, where is it going? Is it below or above 2? It is going to be above, because everything is done at the top. That's what we have. Now, 3 is becoming a little bit complicated. It says push the result of popping out an element plus taking the element at the peak. Let us go from left to right, because that's how operations are. S pop. If we pop an element from this stack, it is 4 we are going to remove. And once you are removing 4, we are coming back at this level, because pop removes the element at the top. So when I remove 4, this operation will return me 4 as value. Then my stack will be like this. Then pick, remember, pick does what? It returns the element at the top of the stack without removing it. When I remove 4, this is how my stack is actually. So when I will use spick, it's going to return 2, but my stack will still remain like this, because pick just return the element at the top, but it does not remove it. So spick is 2. So this number 3 is indirectly telling us that I should push 6, because this is 4, this is 2. When you add, it gives you 6. So when you add 6 to this one, this is what you are going to have. So this is the result of number 3. Now we go to number 4. If I pop an element here, it's going to be 6. Then this is what I'm going to be, because when I remove 6 here, I'm coming back here. Then a pop again. When I remove this element, I'm going to remove 2. And from here, my stack will become empty because from here, when I perform the first pop, I remove 6 as you can see because pop removes. I leave from this one and I become like this. When I pop again, it returns 2. Then I become like this as you can see. So now, after these 2 operations are performed, my stack is empty. And when you do little algebra, you see that this number 4 is indirectly asking us to push 4 because 6 minus 2 is 4. So this is what I'm going to have, dear students. So these are the contents of the stack after operation number 1, number 2, number 3, and number 4 are performed. I hope you are understanding very well. We proceed. Array implementation of a stack. With an array, the first element of the array, which is located at position 0, will be the bottom of the stack. So this is what we have. This is our array here. Let us say this is position 0. This will be the bottom of our stack. The stack will have a fixed capacity normally because an array is a static data structure, which means that if you continuously add items to the stack, it will result in a stack overflow. That is, adding element in a stack that is already full. For this reason, static implementation must include an isFull operation to check whether a stack is at its maximum capacity, just like what we did with a queue. Similarly, stack underflow can occur if you try to remove elements from an empty stack. As the top of the stack will change every time you add or remove an element, the index position of the top of the stack needs to be stored in a variable so that the top can be accessed directly. Initially, the stack is empty, so top will be set to -1. So if top is -1, it means that our stack is empty. We shall use the following global variables. So I have my maximum size, yes. I have my stack from 0 to the maximum size, then top is -1. First of all, is full. We know that if top plus 1 is equal to max size, then our stack is full, just like in a queue. Is empty, same thing. If top is -1, it means that we are empty. The most important here is the push. What happens when you are pushing? First of all, try it and test if our stack is full. Sorry. If it is full, we simply print a message, stack is full. Otherwise, what should we do? Top increases by 1. Then at that position, we add an element. Remember, if our stack is empty, it means that top is -1. When you add 1 to -1, it becomes 0. So you'll be adding data to the stack at position 0. If you want to add again, top leaves from 0, it becomes 1. So now you'll be adding above, and that is how we are adding in a stack. When it comes down to pop, we test if it is empty. If it is empty, we display a user. Another student could simply use is empty directly, just like here he could use is full, or use a different condition here because if top is -1, then it is empty. So at this level, a student could simply say if top is equal to -1, just like here, you could just use this condition directly here. It is still correct. Else, what happened? I first of all display the item. That is, item takes the value in the stack at position of top, then top reduces by 1. Remember that when we were popping element, the value of top keep on decreases. That's why after taking the value at that position, top decreases. That is what we have. Then we return the item. So these are the 4 different operations that we have on a stack. Concerning the size and the peak method, they are similar to that of a queue. And if you are watching this video without watching the one that was done on queue, I will advise you, encourage you to go and watch that video, which is very interesting. It will enable you to understand all the different operations that can be performed on a queue. Now, for the dynamic implementation of a stack, it is done using a linked list, just as for a queue, with the difference that insertion and deletion is done from the same spot, which is the top. Yes. Also, the structure follows a LIFO. Sorry. Applications of stack. 1. Reversing a list. When you want to reverse a list, we mainly use a stack for that. Secondly, parenthesis checker. Remember that in certain operations, be it mathematics, when you open a lot of brackets, the way you are closing, the first bracket you are closing is for the last bracket that was open, last in, first out. And in computing, we are using a stack in order to check all of that. Conversion of infix expressions into postfix and prefix expression. This is the lesson we shall see next class these different expressions and how to move from one to the other using a stack, although there are alternative methods which are more sweet than using a stack. Subscribe to this channel in order to witness all these different strategies that are proposed to you in order to facilitate an A grade in Advanced Level Computer Science 795. Evaluation of a prefix expression, recursion and subroutine calls. We are using a stack for that. Page visited history in a web browser, back buttons. Remember that when you visit a lot of pages on a website, when you click the back button, it brings you to the last page that was being opened, and that is simply a process that is managed by a stack, because the different pages you have visited, it is being stored inside a stack in such a way that when you are playing back, it should bring you to the last open page. Undo sequence in a text editor. Sometimes when you are typing on Microsoft Word and you perform an error, when you press Ctrl Z to undo, it brings you to the last operation that was being done. All of this is using a stack. A stack has a lot of uses in computing, dear students. So, in the next lesson, we are going to talk about the different notations we have in computer science, that is the infix, the prefix, and the postfix. And from there, we shall see how to evaluate each of them. Thanks for reaching to the end of this video. Do not forget to like, to subscribe, and to share in order to increase our community. See you tomorrow. Thank you very much.